Everyone, I'm Amrit. I'm a developer advocate at Google. And today I want to talk about push notifications and how Indian developers are hacking to kind of get the delivery rates a little higher in the region. So let me talk about one of the stats about India. We have about 340 million plus smartphone users, and it's growing at a 16% year-on-year growth rate, which means that your apps have a great chance to acquire more users and have great business in the region. But along with this business, you have also comes with a lot of competition. So there's a greater need to kind of have a better engagement as well as delighting your users. And push notification is one of the mechanisms a lot of developers use in order to engage your users. When it comes to push notification delivery rates, some of these patterns in India actually affect the notification delivery rates. One of them is the user behavior. Until recently, data plans were very expensive for us in the region, and people tend to have the habit of turning off mobile data when they're not using internet. So when they go out of a Wi-Fi zone, they just turn their mobile data off. And that kind of changes the behavior of something like a time to live parameter for your push notification. If you have a really short one and the person has turned the data off during that period, your notification never gets delivered. Recently, we had new carriers who come in and have reduced the data cost drastically. And now this user behavior is slowly changing, but it hasn't changed enough for you to ignore this change. Secondly, we have a lot of devices with custom behavior or custom Android builds, where your notification, and because of battery optimization, they kill off these notification services. They sometimes force close apps, which avoid the app from ever getting the notification delivered to it. So that's another problem. Your time to live parameter, if you actually increase it by, say, from 4 to 8 hours, you see a drastic improvement in, or a large improvement in notification delivery, because you might end up overlapping with the Wi-Fi usage time. So things like that make it very interesting. Like in any other region, notification frequency also, the number of notifications that you send in to the users also affect. And people do get irritated and turn off notifications if you do it too many times. So using collapsible keys and things like that are very important here. Now, I want to talk about 3 design patterns that developers have actually tried out for various use cases to kind of improve notification delivery. One is bucketing of notification. This kind of gives you a better understanding of your user base and how each of these buckets actually work better for you. Let me explain that. The mechanism that they've developed here is that there's a periodic job that runs, refreshes the FCM token, sends it to the server, and when the server gets this data, it actually keeps the user FCM token mapping along with the recency of update. It will also take the timestamp of the update. Now, when you send out a campaign, what they would do is they would split it based on recency. Like, say, for example, you would send your push notifications in the first batch to all the tokens that were updated in the last, say, 7 days. Then the next batch would be to update it from 7 to 31 days, all the tokens that got updated in the last, from 7 to the 31 days, and third batch would be 31 and above. What this allows is that you can fine-tune each of these buckets, the parameters for each of these buckets, to improve notification delivery. You also have a better understanding of who your users, which users would get the notification and might react to your notification better. And because you have a lot of tokens which are not updated frequently, or the users never send that update cycle, you don't end up calculating that into your notification delivery and miscalculating the effectiveness of push notifications. The second one is basically where you have, again, a periodic job that comes in. It checks whether a notification was delivered to the device from the last run or not. If not, it'll go to a service, a REST service, pull the notification, and then display to the user. This is fairly simple to use, but you have to ensure that this does not excessively wake up the device. So this is not the most effective or efficient way of doing things, but still works for it. The last one I want to call out is data messages with a schedule. In a case where you want to send a message like, hey, there's a sale that's going to start at 12 o'clock, and you want to show the message at 12 o'clock for next 6 hours, you have 20% off on this device or on this service. Where instead of sending it on 12 o'clock and hoping that most of your users would receive it, what they would do is they would send this message maybe 2 days before with the last time to live, and as a data message. So the app would receive it. Then based on the schedule that's within the data message, they would schedule a job to come up at the exactly right time and display the message to the user, which means at 12 o'clock, a lot more of your users will start getting that data.
That would be time's up.
Cool. Thank you.
All right.
There you go.
Thank you.